And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to the workshop, where today we're going to attempt to repair the UHF tuner from our little Kolster Brands TV set. Right, so we've been and got ourselves some replacement AF139 transistors from eBay, and yeah, we're going to fit those up. Now, sticky tape and rust made a valid point last time. He said you never tested the old transistors out of circuit, and I think I'd snipped the leads, but I could be wrong. So I tell you what, we're going to do that now. Yeah, so let's stick them in a blob of blue tack, hook the DCA up, and see what happens. Oh, that's not what we want at all. I want to be slightly careful not to bend the leads on the transistor much. Because it'll just I want to form the new transistors exactly the same as the old ones. So that's the lead by the tab. I think blue is the base, therefore leaving the green, I think, to be the collector. Right, let's pop the DCA on. Can we see that on the camera? No, we can't. I'm just going to have a zoom out. And it is saying it's a common anode diode network. Okay. I'm just going to unclip that one and put it to one side. The screen on these transistors, they have 4 legs when they're new, has been snipped off. That was at the factory. So, yeah. Just so we are aware. Let's get the new ones out. So it's these 3 legs nearest me that we're going to need. So there's 1. There's 2. And there's 3. Oh dear, it's a fiddle. Got the hook round the wrong way, which doesn't help. That's it. I think we're sort of there. Except for no, it isn't. I appear to have got the green and the red short together. It ain't going to read like that, is it? Let's just splay them out a little bit. We've got to bend them anyway, so. Analyze. Unknown or faulty components. Now you see, I was a little bit worried about the DCA's ability to test a germanium transistor. That's interesting. Common anode diode network. Does that mean this one's actually all right? Could well do. Now we can of course test a transistor just using the diode test on our normal meter, but that won't tell us if one is noisy or lacking in gain. So let's just field this instrument in for a moment. So which pins are we measuring? Those 3 there. Okay. And I think blue's base, so I'm going to leave the blue on there for a moment. So 0.38 of a volt there. 0.3 of a volt there, and that's about right for a germanium transistor. So what do we got here? So that one did measure sort of the same. So have I made a mistake by measuring with the DCA? Oh, where are we? I'm going on there. No, going on that one. 0.4. Point 0.3. Oh dear. That looks like it might be all right. Where's the other? But it does appear that the peak DCA maybe not the ideal instrument for use on germanium transistors. Now, a while back I did contemplate building a germanium transistor analyzer, but then I bought the DCA, so I never bothered. Right, let's have a look at this one. You can't see that. Let's try it again. Base 0.2, 0.4. Oh dear. One thing we haven't done is base emitter, did we? Bit leaky, as sort of expected with a germanium transistor. So have I wasted my time? We sort of don't know definitively, do we? We have nothing to measure the gain and noise of these transistors that I have now removed from the tuner. I think the best thing we can do anyway is just to press on with our original idea and replace these transistors anyway. Now, I'm just going to... Now, when I took them out, I was this way around. They drop in like that, and I'm just careful to try and make sure that when I replace them, that I keep that one is sort of in there. So I shape the legs of the next one exactly the same. I should have left them in the holes, really. That's the one that definitely lives in there, because that lead, let me zoom in so you can see, we've got to keep these leads as identical as possible in length. So are we going to get any more, or do we lose focus if we go much further? Oh, we lost focus. There we go. So you can see that lead is actually cut there. That lead is cut there. And this lead just goes on down to this blob here. So, does it? Yes, it does. I don't want to disturb any of this if I can possibly avoid it. So I should cut that transistor the same, the new transistor, the same legs as those ones. This one is exactly the same, except for the leads are a little bit more complex down there. We'll put these bars back on the top. We'll fit the tuner and see if anything's better. The other thing that we've learned a bit was the performance of these UHF tuners. Oh, let's zoom out again. Performance of these tuners wasn't exactly stellar anyway. And if you actually look at the spec sheet for the AF139, you fact see it's got a transition frequency of 550 megahertz. Well, channel 68 that this tuner allegedly tunes up to is sort of 850. So, I mean, we're well out of luck by the time we've got up there. So, yeah, there we have it. Right, so let's try it, shall we? I'm still yet to work out what's in here, actually. This is sort of, I think this is where the IF is fed through from one tuner to the next. Does that sort of slide off? Is it soldered? Is it just sort of clamped in place? Let me put these out of the way so we don't wreck them. Let's try and get that plate off just to see what's going on in there, really. Sort of tap it off. There it goes. So we've got a bit of a tuning. What's going on in there? So that's feeding. There's a pass through. That's ground. There's a pass through there. That's going to that. What the blazes is that? Some sort of diode? RF magic going on in there. I'm just going to put that lid back on there. I forget we've ever seen it. It doesn't look like there's anything much to go wrong in there anyway, so yep. We shall put that down to experience. We've had a look. And there we are. A bit more. That's it. Okay. Replacement of transistors, I think. If this doesn't work, I have in fact got an auxiliary plan to retrofit another tuner. But I'm waiting for some parts for that. And quite frankly, I'm having a bit of a mare with an eBay seller who's yeah, not very good, but such is life. Oh, right, let's get these transistors out and get the leads formed. Maybe we should do that one first, being as it's out already, and we'll go from there. Right. Okay, I've got the two transistors, old one here, new one here. I've got them sort of orientated in the same direction. So what I want to do, try and form the legs. To a similar pattern. I could use a little magnification to help my dear old myopic eyes at this point. This is where you get a nice shot of the back of my head, isn't it? Right, let's just have a little look close up and then I'll get out of the way again. Yeah, I reckon I'm quite pleased with the position of that lead. It may want to come up just a tad. Yeah, alright. And this one sort of goes up and off a bit. What I really want is two pairs of tweezers, isn't it? Have I got enough pair? I don't believe I have. Right, so I'll just sort of form that one. Up like that. How are we looking? Let's just turn that around so they're both matching. Needs to go up more like that, and that one needs to still come round a little bit. Yeah, I reckon that's somewhere near. Right, where's my super snips? I'm not going to use those ones, I'm going to use the other ones, which are over there. So, the shield lead, which is that one there, that's something I didn't measure. I wonder if the shield's gone short. It's grown tin whiskers. AF139s, are they renowned for that? Don't know. Right, let's just snip that one off. And I'm going to snip this one slightly long, all the other three, slightly longer than the existing leads. Just so I've got a bit of overlap to work with and solder onto. Okay, how long's that one? That's about there. It's about there. Okay, let me zoom out a bit. We're back. Where are we? We're over here. That's pretty good. Right, So now we've got to get this transistor in that hole there and work out where it wants connected to. And I know the tang was bottom left. So, yeah. I just need to see where this insulator goes. I think it went right down the middle, to be honest. I'm going to push him to one side for the time being, or moving an inductor. You see, you've got to be so careful. There's guys on forums telling me, you know, this was never a problem. They used to do them in the field. Well, good for you, boys. I don't think I'd fancy it. If there was a lightning strike in a client's home, they'd be there, putting transistors in while the client watched. Gosh. Yeah, that sort of insulated spacer. Am I even in shot still? Oh, I am. Just going to lift the transistor back out for a second. This sort of insulated spacer here, it goes straight down the middle, I think. Could be a little bit difficult to do. I wonder what its purpose was. I mean, it might be some sort of dielectric material that actually changes the response of this stage. Who knows? But I'll tell you something, it's in the blasted way. Ah, no, it comes flooding back. I know exactly where it goes. It's at the top. Goes in there to hold that lead out the way. This then solders, I believe. Oh. Yeah, that solders to there. Good, we're in pretty good shape here actually. That can solder onto there. That will solder nicely onto there. Yeah, I think we're in excellent shape. I'm going to do the base first. Let me put this transistor out of the way. That's the one we've done, isn't it? So I'll put that to one side. Okay, still in shot, good gosh. Soldering iron on. We'll want some Serra. We'll get the iron out and put it over here. Just going to go in and solder that base first. I'm half tempted just to trim him down a bit. He is a bit longer than I'd like. So, let's have a little snip. Yeah, that's... It's allowed me to get much closer with that. Right, that's the base in. Let's get our collector in place. Okay. And come round to the emitter. Needs a little tweak, just a little tweak. In fact, I'll tell you what it would be better with it, if I put this sort of shield completing device over the top just to hold the insulator out the way, then that will help us greatly. Yeah, right. I'm just gonna make a small change there. Let's just clean the tip a bit. Better. Right. Where am I looking? No, I am over there. Cool. That is fine in there. Got him. Okay, so that's our. I suppose that's local oscillator, maybe. I don't know. There we go. Right, let's take this transistor back out. Stick it in the blue tack. Form it up. Form the new one up, and make those connections. That one looks a little bit physically like it might be easier to do, which would be nice. And that is soldered. Right, that's pretty rapid progress. Loving it. Right, let us put this back on. What came next? The cover, I suppose. I'll retain all this lovely copper foil, even if the foam insulation on the back has gone a bit unpleasant to deal with. That fits on there. Let's put these 3 screws in. Let's work out how this thing goes now. Although it only seems like last week I did this. In fact, it was a while ago. I don't always publish the videos in the same time as you see them, so they often go out in a little bit of a different order, which is why I don't think anybody's ever commented on it. The subscriber counter on the wall, often I have a lot less followers than I did maybe the week after, if you're with me. So, or the week before. It's because followers, subscribers is the word I'm looking for. It's not Twitter. Right, so there we go. That is back up together. Is it going to be any use? Only one way to find out, isn't there? Just to put it in and see what happens. Might as well check these resistors while we're here. I'm not going to fiddle with any of these tuning slugs here or that one, because I don't know what I'm doing. Right, let's just check the value of those, shall we? So what have we got there? Zooms. Where are you? You're there. Can you see? No, shadow. Made it worse. Have a look over there on that camera. Right, what's this? 140K. What am I looking at? 1.2K. Yeah, it's 1.2K. This is Yeah, sorry, that is 3.4. It's not 3.3, is it? What's going on there? Let's just fetch that off that end. Is that supposed to be 3.3K? Does that actually mount through a hole? It does. Thought it was wrapped round, but I think it's actually going through a hole. Fair enough. Oh, play the game, man. That's it. We're away. What are we reading? Just check that one again now I've opened it. Hey, 1.4K. Ah, yeah, 1.2, 1.4, that's near enough. And this one is 5.3. That's more like it. Right, okay. Everything was fine there. We need to worry about that. What have we got in there? Can't really read it through that sleeve. Powers names? Brown, black, red. I'll buy that. Good values. Right. Let's put that back down. Right. Let's go and put it back in the set. Okay, so this is where we sort of left off last time. We just got to remember what goes where. Thankfully, some bloke made a video on taking these apart. I marked the green connection there. Ooh, the camera looking at that. That one there. That's where the green wire here lives. The coax input. Yes, it's across those two. Brilliant. And the output is across there. Those two there. I've switched to the big tip so we can put a bit of heat into that when we get there. So the first thing to do is probably reattach this fella. So that's our IF output, which then feeds the VHF tuner. I believe there was a comment, probably from an American chap, who said, don't you have to select a UHF position on the VHF tuner to enable it to pass through? Yeah, very common on American sets, but we had two different incompatible television standards on the two frequencies in the UK. So all our 625 line pictures were on UHF, and all our 405 line pictures were on either bands 1 or 3 VHF. So the standard switch on the front here actually provides the switching. At least I think it does. I have to say, I've never met it done any other way. I might well be wrong, of course, and that may be the fault. I think we sort of proved it by putting the pattern generator on it last time, but hey, every day's a school day, isn't it? So this is getting to be awkward because this green wire is far too short. Let us get something to just rest that on momentarily. Here's Mr. Fluke going to help us out here. No, it's too short. The other way now. Oh, let's get the coax on first. Lovely. Right, I've just got to wrestle this green wire into place. Oh, that's working well. Let me just flux him up a bit. Fresh solder, always better with fresh solder. Okay, that's in. Now, 3 screws on the back is the next job. I'm slightly worried about where I've left my screws, actually. We shall find out in a second. I thought they were in a magnetic tray, but I don't think they are. So that has got to come this way a bit and drop down yet. Gosh, it's all in there, isn't it? Oh. Right, I see. It's got to go behind that little clip. Probably got a lovely picture of my head again. You people must be very familiar with the back of my head now, my thinning hairline. What have we got in there? Right, pot of Bart's located. Knobs could do with a bit of a bath, as could the case actually. We'll do that later. We have got 3 short screws to go in this tuner. 1, 2, 3. Right, screwdriver. Position where I can get at the things. I think this may call for a blob of blue tack on the end of the screwdriver trick. Because let's be honest, no amount of magnetism is going to help with a slotted screw. Got it? It's going to be about there. I just dropped the second screw. Oh no! Right. Oh, there's one. God, caught right at the top of the wiring loop. Oh, and that bit of circuit board there. Oh dear. Got it. Right, that's one. There's one more to find. Finally, the third and final screw. Right, that's the UHF tuner back in. Where's my frame valve? Let's pop him back in. PCL 86, frame or audio in it. Expected frame in here. Right. I guess it's time for the moment. Oh, I've got to put the aerial panel back in. And then it'll be time for the moment of truth. What's the betting? Same or different? Same or different? Place your votes now. Subject, shall we? Right, it's time to power up. So power's going on. Let's wait for the valves to warm. Oh, there we go. And I have to say, it's still very, very weak in contrast, and no trouble syncing, isn't it? Looks better on the camera than it does in real life. I think we've still got a very real problem here. So, yeah. Right. The one good news, of course, is we've managed to get away with changing those UHF transistors in the tuner, despite the fact we were told not to. But yeah, it's still very weak. Right, let's go and have a look back at the schematic and see what we can check next. Right, back into the schematic. So this is our vision detector valve here. So A is 405, B is 625. There's not much in here. What I was thinking is maybe there was a DC condition wrong on this valve, which would maybe put a DC offset on, which is upsetting the diode. But that doesn't seem to be the case. It's transformer coupled, so that can't really happen. Then I look down here into the cathode circuit. So cathode comes out of here, usual sort of resistor and capacitor network to set the bias. What's all this doing though? So we've got an inductor, L56. We've got a capacitor, an electrolytic capacitor, that C64, and then we've got a switch. So A is 405, where an additional resistor is put into circuit, and then B goes up to M, which is our UHF HT. So what if that's wrong? Because, well, I don't know, R57 or L56 or C64 leaking could be the problem, or maybe the valve itself is tired and it's fine when it's in A but not enough when it's in B. So we need to find out what sort of voltage we can expect on B. So if we go down, so where are we? V6 EF184, anode, screen, 205 volts. So we've got 13 volts on our cathode. 13 volts, pins 1 and 3, look, 13 volts should be available to the UHF tuner. Let's just measure that and see where it's at. Okay, so I have located, that is the part of the system switch here that switches the HT to the UHF tuner. That is possibly our errant capacitor. That yellow thing there is the coil. So on that point there, we should have something slightly less than 13 volts. So switching on the power, obviously we won't see any voltage here until the video detector diode, the video detector valve gets warm and starts drawing current. So yeah, hold tight. Right, we have a picture. We've got 3 volts HT going to our tuner. No wonder the poor lad's not working properly. Right, let's do a bit of fault finding. Switch that off. So, what do we think? SAD valve maybe? Or do we think this capacitor's leaky? This is a job for our flash new capacitor tester. So, right, I shall switch the peak ESR meter on, monitoring for component. Okay, so it goes between ground there and that tag on the switch there. Oh, open circuit, low capacitance. I just bent the probe, that was careless. Alright, let's go again. .82 microfarads and an ESR of 4.4 ohms. ESR's not exactly spectacular, is it? But and the capacitance has risen, which sort of worries me. I don't like capacitors that have allegedly had their values rise, because it generally means there's a failure going on with the ESR. So I reckon I should just, for the sake of tuppence halfpenny's worth of bits and what have you, just snick him out, and we'll tack another one in temporarily, and we'll switch on and see if we get more than 3 volts. Right, so 10 microfarads we're going to need. 10 microfarads. Right, what's that? 63 volts. Well, that's ample. What I'm just going to do is I'm going to cut that there. Just lift him out of the way. He won't be staying, so I'm just going to just tack across there in a very temporary manner. Oh, I might as well snip the other end off as well. Yeah, let's tin the end up. I'm amazed that tuner's doing anything at all with just 3 volts on it. That's quite impressive. Cool, look at that, just about long enough. If this fixes it, we shall make a more permanent repair. Right, nothing's touching, that looks good. So let's hook our meter back on. So, might as well hook straight across the capacitor. Right, are we in shot? We are, lovely. Carrying on. Well, that doesn't appear to be that much better yet. Let's wait until we're up and running. Oh, we are up and running. Okay, so we have got a problem with our cathode voltage. It's far too low. Right, let's just switch off. So it is entirely possible that our video valve is just low emission. It's also possible that the anode resistor, because all the volts come from the screen and anode, that's the only supply we've got to the valve of 208 volts, 205 volts, that maybe that is low voltage. So I'm just going to follow that back and we'll work out which pin, which was the pin. Anode is pin 7. Pin 7 and 8. Well, that should be quite easy to find. Except for it's all sort of buried in there. Right. Okay. So, how is it connected to... Oh, it's connected to that transformer. And then I think pin 7 is going to be... Sorry, pin 8 is going to be... So 7's the anode, 8 is the screen. The screen goes right up to the top. So that's where I want to measure, really. Okay. So pin 8. I'm really struggling to see in there. Let's put a bit more light on the subject. Let's have a look for R53, which feeds the screen on the diagram. So R53, it's going to be in that section again. R53. I think that is R53. That's 2.2 mega. That seems very high. That's a screen supply, I suppose. R53. It is indeed 2.2 mega ohms. Right, so let's just check. We've got 205 volts on there. No volts at all. Now that should come up as soon as we've got HT. So, right, we are making progress here, aren't we? So, what's on there? Other end of R53, 230 volts. Okay, has R210 gone open? Were we not making a good contact? It is 2.2 million ohms, so yeah. There's nothing there at all, is there? Beginning to wonder how it was ever even working in 405 line. Right, so what resistance is that actually measuring? Might not want to measure it in circuit because it's... I'm getting negative resistance values. Let's just lift one end of it. Measure it now. Ha! Well, there you have it. That says OL for open circuit and nothing there at all. Our 2.2 mega ohm screen resistor is open circuit. Jolly good. Let's see if we can find another. Not many left. 2.2 megs. Right, so it goes between that tag there and that one there, missing out that middle one. Okay, so just desolder that from there. That's a very densely populated tag, is that one? I'm just looking at that. I'm wondering if that has been replaced before. And if this is gone, what's our anode resistor like? You remember this is actually working in 405 line. So, I mean, both of these components are in circuit. I suppose though, the tuner for 405 line is a valve tuner, so it's fed from our 205 volts. We haven't got to rely on a 625 line signal. HT coming from that cathode circuit. So, will this provide us with a cure? I wonder what the anode resistor's like. Perhaps we should check that in a moment. Let's get that just tacked in loosely. Right, switching on again. Oh, I want to measure the voltage on that capacitor really, won't I? Oh, wow. Can you see that? That's the HT to our tuner now. 12 volts. No signal because the aerial lead isn't in. And I have masses, and I mean masses, of contrast. Yep. Ha! Would you believe it? There we have it. All that the problem was a 2.2 mega ohm screen resistor. Yeah. Right, let's show you the pictures now anyway. In fact, I might just be able to wiggle the camera around. Oh. This side, look at the contrast. That's fabulous now. Pots of it. That's our problem solved. I've just been looking at the diagram as well because I was taking a couple of screenshots to edit into the video, and I realise I've made a mistake. R55 feeds the anode via R56 and it feeds the screen here. R53, which is our 2.2 megohm that we've actually changed, is a voltage divider here which biases this stage. But here's the thing. So we've got a potential there. So in B it sets up a bias on there, look. B. So R53 goes up via R54. It's all of this bit that was out of kilter. So yeah, pay attention to the diagram, Doz, because R53 was your problem. 2.2 meg. I wonder what R52's like. What value is R52? Oh, he's only 100k, look. So yeah, that's the betting he's all right. Anyway, pots of contrast now. So despite the fact I misread the diagram, we found a fault, and it's that resistor there, R53, low contrast on 625. Right, it's just tidied up our new 2.2 mega ohm resistor there, and our new capacitor in there with a bit of sheathing on the leads to stop it shorting out of it. It's very compact in here. Right, what remains now to do really is to give it a bath, give the outer case a bit of a bath, and yeah, put it all back together. It's working very nicely indeed. One thing I have got to do is fit a new suppression capacitor. As you can see, it's very much smaller than the one that's in there now. This is 47 and 310 volts class X2. What I'm planning to do is just mount it there, because if I've got to get that one out, it's going to be very, very difficult. So it's going to be a really big bit. And let's see if we can't just get... Well, there is a ground tag there. I wonder if I can just get in there and just solder it onto that bit. Across those two pins there would be very acceptable. Just tin the new one up a bit. I was contemplating soldering it straight to the chassis if I could get the chassis to take solder, but no, this will be better. Okay. Brilliant. That's in. Good. Right. Let's pop the case back on, which is drying out and out in just outside the workshop. Oh, let's rid of the solder block. Okay. There we are. Pity about this edge, but you know, it's just where the plastic's been abused over the years. Age, what is it? Some marks commensurate with age and mileage. There we go. Yeah, it's a bit of a shame, isn't it? But it's just starting to become brittle. I think that's its problem. It's interesting, the chassis now no longer wants to fit back inside the case. So there you have it. Pots and pots of contrast on 625 now from our little Kolster Brands KV003. 405 line picture I think has still got more punch to it, and this is the simple reason is in the circuit diagram the video amplifier, when it's switched to 625 lines, is AC coupled, therefore the black level tends to move up and down a bit, and there's no DC restoration in that quite simple circuit. 405 line doesn't have that problem. So yeah, the video's not quite as crisp as 405 lines is. But there we go, a successful little repair eventually, even if it was almost by accident. Anyway, thanks for watching. Click like, subscribe, do all that rubbish, and I'll see you very soon here on Doz's Television Workshop. Bye. Hello and welcome back to Doz's Television Workshop, where today we are going to carry on looking at our Kolster brands. What's the model number? Hello and welcome back to Doz's Television. Got it wrong. God almighty. Hello and welcome back to Doz's Television Workshop. I'm slightly out of shot. For God's sake. What the frick have I done with those? I put them somewhere, but heaven knows.